All right, for the first part of the set questions for the Unit 4 Lesson 1 homework, the directions are a little murky, so let's clarify them. For each question provided below, and this is just 7 through 10, we're not actually solving this equation, but we can. We are asked to identify the first operation performed on the variable and also identify the last operation performed on the variable. Then we're asked to determine the first step that would take place when solving and the last step that would take place when solving. So when we are asked to identify the first and the last operation, let's go back to the order of operations for a moment. I know you may have learned PEMDAS, but we said that's a little incomplete for high school. So for GERMDAS, that we said G stands for grouping, R is for radicals. When I am identifying what's happening to the variable, that is similar to evaluating what is happening. And that follows the order of operations. The second thing that we're asked to do is determine what we would do to solve. And when I solve, that is when I'm working backwards using inverse operations. So in question 7, I would say the first thing that is happening to X. So I'm going to maybe just write happening to X. The first thing that's happening to X is that 8 is being subtracted from X. So again, I'm looking for grouping. I do have grouping in the form of parentheses, and within my grouping, the only operation in there is minus 8. So I'm going to say 8 is subtracted from X. All right, the last thing, so it said identify the first and the last operation. Oh man, well, after we subtract 8 from X, we would then have multiplication, right? Because we don't have any exponents or radicals. The last thing that's happening on the left-hand side is that addition. So I'm going to say last thing that's happening is that we are adding 7. And really not just X, but at this point we're adding 7 to 8 less than X times 3. So adding 7. So we're like halfway done with this. What the second part of the directions are asking us to do is determine the first step that would take place when solving and the last step that would take place. So the idea here is that we could really do it from the information we just wrote down. We know that when we solve equations, we solve using the opposite order. So I start with addition or subtraction, and I use inverse operations. All right, so since the last thing that's being done to the expression with X is that we're adding 7, my first step to solving is I'm going to subtract 7 on both sides. So again, the order is opposite, and instead of adding, I'm using the inverse operation to undo that addition of 7. All right, and then the very last thing that I would end up doing, and again, you can solve this if you wish, but the last thing is that I would end up adding 8 to both sides. So when I say both sides, I mean both sides of the equation. All right, so that's really the gist of these. If you were confused about the directions, I would encourage you to pause the video and maybe resume in a moment when you've had some time to think about these. I'm going to keep rolling though. So for number 8, oops, let me do this in 2 different colors to offset. How about this? I'll write it on the left-hand side. If I consider what is happening to X, I don't really love the word happening here, but whatever. It's what I'm going to go with. The first thing that's happening to X is that it's getting multiplied by 4. And then the last thing, and I think this one's easy because there's only 2 things really happening, is that we're subtracting 12. So to undo that, if I were to work backwards to solve, my first step in solving would be to add 12 to both sides of the equation. And the last thing that I would end up doing is divide by 4 on both sides. So what I mean by that, like the first example is a little long, but if I asked you to solve this, we've been solving some of these in our practices, we would add 12 to both sides. And that would be what, 40? And then the last thing we would do is divide by 4. Okay, we got 2 more that are like that. In number 3, if I think about what is happening to x, if I were to evaluate x, this is the order in which I would evaluate what's going on, evaluate the expression rather, on the left-hand side. So the first thing that's being done to x there is x is getting multiplied by 2. So again, in that order of operations, when we say GERMDAS, the reason I use a G is there are parentheses here that we can't see, and within those parentheses, I can, well, rather there's grouping there that we can't see with parentheses. Within the parentheses, I see that x is being multiplied by 2, and then we're adding 8, so we're following the order of operations. All right, so the last thing that's happening here is the division of 3. And even though division comes before addition in the order of operations, again, this is why we use grouping instead of parentheses, because we had grouping in the fraction that we didn't have parentheses for. So I would say that last thing is that we are dividing by 3. So when we go to solve, we said we're going to undo what is being done to x using the opposite order and inverse operations. So the first thing I would probably do is multiply both sides of the equation by 3. And the last thing we'll end up doing is divide both sides of the equation by 2. So if you're not sure, feel free to work it out. I'm going to work it out real quick. So again, if I'm solving this, I would probably multiply by 3 on both sides. That would give me 2x plus 8 equals 24. Then I would subtract 8 from both sides, which would give me 2x is, 16 hopefully. Then that last step is we would divide by 2. So again, we can see what we would do just by thinking about what's being done to x and in what order. Now, number 10, we could argue about this one. I think if we were to say literally the first thing that's being done to x is that it's getting multiplied by 2/3. And then the last thing that's being done is that, now you could distribute the 5 if you want. I would say x is being multiplied by 2/3. And then at the end, everything is getting multiplied by 5. So to undo that, to solve, you could start by dividing by 5 first. And then the very last thing you would do is unmultiply by 2/3. That is the same as dividing by 2/3, which is multiplying by 3/2. This one's tricky. So I'm not saying that you can't distribute. I know in class a lot of my students chose to distribute that 5, but I think you're going to make it easier on yourself if you just divide it off first. So like if I divide this side of my equation by 5 and this side, I would have 2/3 x minus 8 equals 8. Then we could add 8 to both sides. So we'd have 2/3 x equals 16. Then to divide by 2/3, that's the same as multiplying by 3/2. And of course I would get, let's see, 8 times 3, I would get x is 24 if I did that. All right, the next part of the practice, I think, is a little more straightforward. We are just asked to solve and check each solution. So how about this? I will solve a couple on the left, and then I'll just write out the solutions to the ones on the right-hand side. You may have noticed that when I solve, I like to kind of show a dashed line through my equal sign. You don't have to do that. It just helps me make sure I'm doing the same operation on both sides of the equal sign. So I know I'm going to add 6 to both sides first. 36 plus 6 is 42. And then we would divide both sides by 3. Let's see, so 42 divided by 3 is, I think, 14. But I should double check that. Let's see, 30 plus 12, yeah, 14. All right, so in number 12, you could really do a couple things first. You could start by adding 12 to both sides, or you could distribute the 9. I would encourage you to try this one in the order that seems to make the most sense to you. I'm going to do it in maybe a different order. I'm actually going to add 12 first to both sides. So if I do that, on the left-hand side, I now have 9 times 2n plus 5 equals, let's see, 51 plus 12 is what, 63? All right, so again, you could distribute the 9, or I'm trying to do this in a way I think you guys won't. You could just divide both sides by 9. So we get 2n plus 5 equals 7. And then from there, it's pretty straightforward. We could subtract 5 on both sides. 2n equals 2, divide by 2, n equals 1. Don't forget, you always have the power to check your work. It kind of drives me crazy a little bit when students ask me, like, is my answer correct? Just check it, plug it in. So to see if it's correct, we could substitute 1 for n. So we would have 9 is 2 times 1 plus 5 minus 12 is 51. So 9 is 2 plus 5, which is 7, minus 12. Let's see, 63 minus 12 is 51. That works out. Now, if you chose to distribute first, combine like terms, and then solve, you should still get n equals 1. All right, lastly, number 13. Again, you can decide if you want to distribute that 4 right away. You can. What I would probably do first, just to get rid of the fraction, is multiply both sides by 5. It is not wrong to distribute the 4 first, but when we multiply by 5, I now don't have a denominator of 5. And of course, 8 times 5 is 40. All right, so here you go. You could either distribute that 4, or you could divide everything by 4. The reason I like to divide everything by 4 is it expedites the amount of work I have left. I don't have to distribute and then do 2 more things. I'm just almost done. So if I divide by 4, I get b minus 2 is 10. And then, of course, I add 2 to both sides. B is 12. So if I just check this one, doing mental math, 12 minus 2 is 10, times 4 is 40, divided by 5 is 8. It checks out. All right, I want you guys to try the last 3. I'll work them out, and you could just check your solutions. All right, as you work questions 14, 15, 16, those are the solutions that I got. I hope I'm correct. I'm sure you'll let me know if I'm not. I do expect to see work on your paper. I will not accept just those solutions.